Here is what every HVAC company will tell you. If you want real cooling, you need a compressor, refrigerant, and a bigger monthly bill. Here's what the numbers actually show. They say cool air must be manufactured. The data says the Earth stores it for free. They say July heat has to be fought with machinery. The ground says otherwise. Most soil in much of the United States sits near 50 to 55 degrees Fahrenheit a few feet down. That number does not care what your utility charges. It does not care what brand name sits on your condenser. It just stays there, day after day, year after year. You already live on top of a temperature reserve. You just were not taught to use it. You were taught to rent comfort back from a machine, month after month, summer after summer. Think about what that means. Your hottest air is above ground. Your coolest, stable air is below it. One costs you every July. The other shows up with the property tax. They say the smart move is replacement. The ground says the smart move is contact. They say more tonnage. The soil says more length. They say buy a better box. The earth says bury a simple path and let physics work. Once that clicks, the sales pitch starts sounding strange. Why are you paying to manufacture what the land keeps storing? Why are you financing moving parts when the quiet part has no motor at all? You have probably been told that your air conditioner is the only honest way to keep a house livable in summer. Most people accept that. I accepted it for years. Then I looked at the real comparison. 95-degree air above ground. 54-degree soil below it. One number is what you suffer through. The other is what you already own. They say efficiency means buying the newest unit. The data says the biggest temperature drop in your yard costs less than a service call. They say the answer is more equipment. The ground says the answer is depth. And that is where this starts to bother you. Because once you see the spread, you cannot unsee it. 41 degrees. Not fantasy, not theory. Just a temperature difference sitting under your lawn. Nobody told you. Not your builder. Not your contractor. Not the man who sold you a bigger condenser. You were taught to look at the thermostat. You were never taught to look down. The old builders looked down first. They watched where milk stayed cool. They watched where carrots lasted. They watched which rooms stayed quiet in August. Then they built around that fact. Modern cooling trained you to forget it. Ancient builders never did. Amish families never did. And the reason matters. Because once you stop thinking like a customer and start thinking like the earth, the whole game changes. You stop asking how to create cold air. You ask where cold air already lives. That question sounds small. It is not. It flips the whole industry upside down. Instead of treating heat as an enemy to overpower, you treat it like something to redirect. Instead of burning watts to force a result, you borrow a condition that already exists. That is how every durable trick works. A root cellar is not a trick. A spring house is not a trick. A banked wall is not a trick. They are agreements with temperature. They do less, so they last longer. The Persians did not read this in a textbook. They figured it out the way all real knowledge gets discovered, by paying attention to what the earth was already doing. Amish builders did the same thing. They watched where butter held. They watched where apples lasted. They watched where August lost its teeth. The answer is 6 to 8 feet below your feet. The answer is a buried path. The answer is moving hot air through cool earth slowly enough to trade heat and cleanly enough to keep it dry. That is all this system is. Not magic, not a miracle box. Just a simple ground-coupled air path using stable soil temperature to shave brutal heat before it reaches your rooms. In the right house, with the right run, that cut is not small. It can drop the cooling load hard enough that summer electricity falls by 63 to 74%. In some houses, the whole bill follows. The reason you were never told the real number is simple. This system was written out of the building conversation in the last century. Someone had a very good reason to keep you in the dark. Here is the promise. Learn one buried principle. Learn one forgotten layout. Then you can turn 95-degree air into air in the high 50s before any compressor touches it. And yes, this works even if your house was built 50 years ago. Stay with me, because what I found in Lancaster County uses the same physics the Persians used to make desert heat livable 2,000 years ago. The science is embarrassingly simple. The deeper soil gets below the daily weather swing, the less it follows the afternoon heat. That means the ground becomes a slow battery for temperature. It absorbs summer heat. It releases winter cold. It moves gradually, like cast iron, not like sheet metal. The United States Department of Energy uses the same logic when it rates ground source systems. Its December 2024 geothermal guidance lists efficient units at a coefficient of performance of 3.6 and the best available at 4.8. That means 3.6 to 4.8 units of heating or cooling for every 1 unit of electricity input. Less efficient equipment sat at 3.1. The field calls that coefficient of performance. You call it getting more work from less power. Natural Resources Canada gives the buried air version in plain building terms. Its earth-to-air thermal exchanger guide is blunt. Put the pipe at least 1.5 meters deep. Run it 30 to 40 meters long. Keep a 2% minimum slope for drainage. The Air Infiltration and Ventilation Center gives the tighter band many builders use. Bury the run 2 to 3 meters deep. Keep the diameter around 0.2 to 0.3 meters. Expect strong summer temperature drops when the run is clean and dry. That last part matters. Dry is performance. Wet is trouble. Natural Resources. Canada warns that ribbed pipe holds moisture and invites bacteria and mold. It also warns against drainage holes where radon may be present. Smooth walls, sealed joints, controlled drainage. That is the whole difference between a working system and a swampy mistake. Think of it like your body on a hot day. Blood moves past cooler tissue and dumps heat. An earth tube does the same thing with air and soil. Hot air enters, heat leaves. The ground takes the hit. Your rooms feel the difference. That knowledge never disappeared. It was written out of the manual. It was waiting. And that gap represents a massive market in equipment, refrigerant, installs, and service every single year. That is why you have never heard of this. I first felt the difference in East Hempfield Township, just west of Lancaster. Outside, the gravel threw heat back into my face. Inside a stone spring house and the banked storage spaces beside it, the air stayed still and cool. No compressor barked, no fan whined. I could hear water and my own footsteps. That was it. I asked a man named Eli why the room felt older than the weather. He smiled. He tapped the stone. Then he told me his family still trusted what stayed cold underground before they trusted any machine. 4 generations, he said. Maybe more. I remember the details more than the words. Damp limestone. A wooden shelf worn smooth at the front edge. A jar sweating quietly in shade. Outside, tires hissed on the road. Inside, the room barely moved. That absence stays with you. That line did not come from nowhere. Families from the Palatinate, Alsace, and Canton Burn brought cellar, bank barn, and spring house habits with them into Pennsylvania. They built for storage first, then comfort followed. The Pennsylvania Historical and Museum Commission's 2013 Lancaster Plains study says spring houses supported home dairying and preserving food. Its field guide says root cellars held around 50 to 55 degrees below frost line. The old rooms were not decorative. They were working climate control. Go back far enough, and you see the same answer repeating. In Yazd, Persian builders used wind catchers and qanats to drive hot desert air downward over cooler subterranean spaces and water. The tallest working Badgir at Dawlatabad rises 33 meters. The principle is still simple. Use height to move air. Use earth to take heat. In the ancient Southwest, semi-subterranean homes used the same thermal truth from the opposite direction. Sink part of the room below grade, wrap it in mass, and the wild swing outside stops reaching your body. Different materials, different continent, same lesson. Every civilization that mastered extreme heat arrived at the same answer independently. The Amish never forgot. They carried it from the Palatinate to Pennsylvania 300 years ago. They kept building it because it worked. They never needed anyone's permission to do what made sense. Here is where the anger starts. In 1902, Willis Carrier solved a printing problem with mechanical cooling coils. In 1915, Carrier Engineering Corporation turned that idea into a business built on machines, installs, and recurring service. Every house that cooled itself with design threatened a future equipment sale. The lock-in came through standards, habit, and post-war housing. ASHRAE traces its roots to societies founded in 1894 and 1904, then merged in 1959 around heating, refrigerating, and air conditioning engineering. Yale's Energy History Project shows passive solar design stayed active through the 1930s and 1950s. The formula was clear. South glass, narrow plans, calculated overhangs, then cheap fossil fuels and marketable devices took over the conversation. That was the real replacement, not better physics, better marketing. A house that needed less equipment did not create an endless revenue chain. A house that depended on branded parts did. The quiet knife was regulation. A federal report on passive solar health and safety warned that strict enforcement of existing codes could substantially restrict common passive techniques. Read that again. Not because it failed. Because prescriptive codes favored conventional construction and conventional equipment. The allies were obvious. Carrier and appliance makers sold the hardware. The Federal Housing Administration favored repeatable post-war house templates that lenders liked. Shelter magazines and cooled theaters sold the dream of mechanical comfort to the public. Money moved through all three. Standards fed mortgages. Mortgages fed subdivisions. Subdivisions fed equipment sales. An entire field of knowledge disappeared from architecture schools, building codes, and contractor habits, not because it failed, because it wasn't profitable. And the modern version is even less subtle. InfluenceMap says gas and utility groups ran a coordinated anti-electrification campaign from 2019 forward. In Colorado, the pattern showed itself again. Energy and Policy Institute reported that Black Hills Energy disclosed $426,906 in lobbying expenses for 2021. Atmos Energy disclosed $49,500 for a lobbyist. It also fought pro-electrification code changes in Gunnison. The American Gas Association took in $36 million in 2019. It disclosed only 4.7% of dues as lobbying. Internal records showed far more going to government affairs and public policy. Same tactic. New decade. Keep the customer tied to a bill. Keep the official tied to a standard. Keep the builder tied to the familiar estimate sheet. Nobody told you. Not your builder. Not your contractor. Not the man who sold you the upgrade. The HVAC and utility protection racket is enormous. The U.S. HVAC services market alone is measured in the tens of billions every year. Every passive retrofit installed is equipment that never gets sold, serviced, replaced, or financed. Now, if you already own a house and you're thinking this only applies to people with land, stay with me. Because this next part is specifically for you. You don't need to buy equipment, you need a yard, a drill, and a weekend. What I would build first is the simplest version. I would start with one smooth wall 4-inch Schedule 40 PVC run. Make it 40 feet long. Bury it 6 to 8 feet deep. Hold a 2% slope away from the house. I would keep the intake hood at least 24 inches above grade. I would screen it with stainless mesh. I would place the outlet high on the shaded side of the house. Then I would use a sealed inline fan drawing 38 to 72 watts. Nothing exotic. If your lot gives you more room, stretch the run to 60 feet. If your soil stays damp, add a proper condensate trap at the low point. If your yard is tiny, even a shorter run still preconditions air before it reaches the house. The point is not perfection. The point is load reduction. The parts stay humble. Schedule 40 PVC, a solvent-welded condensate tee, stainless insect screen, a MERV 8 filter box, a short sleeve of HDPE or PVC at the wall penetration, exterior foil-faced insulation at the last 6 feet before entry, a radon test kit. If you want a quieter finish, line the final 3 feet with smooth galvanized duct before the register. The costs are lower than most people expect. Pipe runs $92 to $148. Fittings and primer run $18 to $33. The inline fan runs $57 to $119. The filter box and screen run $26 to $48. Sealant, grate, and condensate drain run $19 to $41. Your radon kit runs $14 to $21. You land between $226 and $410 if you dig smart and keep the run short. Depth matters. Length matters. Clean drainage matters. Smooth wall pipe is not optional. Corrugated drain tile causes standing condensate, biofilm, and mold. Keep the trench bedded with 2 inches of sand below and above the pipe. Keep at least 10 feet from a septic line. Keep at least 25 feet from a fuel tank. Seal every joint. On a 95-degree day, a good run can send air into the high 50s or low 60s before it mixes indoors. You will not turn a leaky house into a meat locker. You will slash the load your air conditioner sees. In shoulder season, you may not need it at all. In peak summer, the compressor cycles less, starts less, and bills less. Maintenance is boring, which is exactly what you want. Check the screen monthly in leaf season. Change the filter once a season. Inspect the condensate drain once a year. Retest for radon every 2 years if your county is known for it. One buried tube will not fix bad insulation, open attic leaks, or a house baking in full western sun. But it does something valuable first. It lowers the fight. It gives every other cheap improvement a better starting line. Shade works better. Night flushing works better. A small air conditioner works better. You stop chasing the peak. You shave it before it enters the house on the worst summer days. Your conventional system costs $6,800 to $14,600 to install. It costs $118 to $247 per month to run in peak season. It lasts 12 to 18 years before it ends up in a landfill. This costs $226 to $410 total. It lasts 20 to 30 years. Your choice. Everything I've covered across this channel, root cellar storage, rainwater quieting, and winter window control, lives in one place. Step by step, season by season, room by room, in the order the families actually use it. Link is in the description. But stay here, because what Eli built is the part nobody is talking about yet. If you're the kind of person who believes real knowledge has been quietly pushed aside, you already know what to do. Someone else profits from that. Hit subscribe. Not for me, for what comes next. This matters more than ever. Because this is not a channel. This is a quiet movement of people who have decided they're done being sold what they already own. I want to hear from you. Drop your state. Drop your worst summer electric bill. Tell me whether your grandparents had a spring house, cellar, or shaded room in the comments. I read every single one. And your answers decide what we cover next. Next week, I'm going to show you what a 1946 Penn State document reveals. It keeps a house warmer in winter with nothing but lime plaster, airspace, and sun. And the report that proves officials knew about it decades before selling you the expensive version. You're not going to want to miss that one.